Hello, everyone, and welcome to Team 74's latest prototype of OS Moses. Before digging into the new GUI interface, I'd like to take some time to discuss the back-end improvements to OS Moses that are not visually noticeable. OS Moses logic deduction capabilities were greatly enhanced with the first release of the collective knowledge system in this iteration. As each mower learns about its local surroundings, it uploads this data to the collective knowledge system, which combines and formats this data to implement a divide and conquer approach to lawn mowing. OS Moses UI was developed using Java Swing Library and is split into two visual views for data and a visual representation of the current state of the lawn itself. The Legend panel provides a dictionary of icons used in the lawn's visualization to describe each lawn square state. Each lawn square is visualized with icons from the Legend view. While most squares will have one icon, some squares will have secondary icons that represent secondary items, such as the chargers for the lawnmowers, which indirectly support mowing operations. The lawn data panel displays the overall data for the lawn itself. Lawn size indicates all the squares within the lawn itself. Squares cut are the current squares that have been cut. Squares are the remaining eligible squares in the lawn itself that can still be cut. Turns taken are the completed turns so far in the current run of the simulation. And turn limit is the maximum amount of turns that are allowed before the simulation itself will terminate. Lawnmowers data panel displays data for all lawnmowers within the current simulation. It shows the mower's ID, direction, position, if it is crashed, and its current energy level. The current mower that will iterate the next run of the simulation is highlighted blue. The control panel shows the three controls available currently to the OS Moses UI. Next, we'll iterate the current mower's turn. Fast forward, which will complete the simulation to completion, and stop, which will stop the simulation at its current turn. And just to show an example of the UI in motion, let's click a few times through Next. As you can see, with each iteration of clicking the Next button, the highlighted mower is updated and the information in the lawn itself is updated with the results of the turn for that mower. Now let's go ahead and click fast forward and complete this turn of the simulation. As you can see, the simulation completed to it reached the end condition of